This is a quick lesson on factor trees. You're going to need the skill of making a factor tree for the primetime book in Unit 3. So as you can see here, we're going to do a few things. By the end of this lesson, you should know what a factor tree is. You should also know what a factor string is. You will be able to find the prime factorization of a number. And you should also be able to use a factor tree to find the prime factorization of a number. So we're going to start with the number 100. You can make a factor tree for any number. We're going to use 100 as an example. A factor tree is just a tool that shows a way to multiply numbers to get a given number. For example, one way to get 100 is 4 times 25. So that's what we would call a small factor tree. From that factor tree, we get a factor string. And the factor string is 4 times 25 equals 100. But for the number 100, there are many factor trees that you can make. You could have made a different factor tree by using 2 and 50, and that would give you a different factor string, which could be 2 times 50 equals 100. You can also take each one of these factor trees and make them branch out more. So if I start with the red factor tree, I can now make a factor tree under 4 and break that down to 2 times 2, which would give me a third factor string for 100. And this factor string is basically how do you multiply to get 100 with the numbers in this tree. So you look at the bottom of the tree and you see 2 times 2, which is 4, times 25 makes 100. So the bottom of the tree, the bottom branches, is where you find the numbers to write out your new factor string. So a third factor string for 100 would be 2 times 2 times 25, because that also equals 100. So I can continue to expand this factor tree by breaking the 25 down to be 5 times 5. So now I have an even little bit longer factor string, because now the bottom of the tree has 1, 2, 3, 4 numbers. So now I have a longer factor string, 2 times 2 times 5 times 5. That also is another way to get 100. This last factor string, if you notice, all of these numbers here are prime numbers. So when you look at the next goal, or the next question, what is the prime factorization of a number? The prime factorization of a number is the factor string for that number that's made up of only prime numbers. So the prime factorization of 100 is 2 times 2 times 5 times 5. That's the prime factorization of 100. If you look over here, you might ask, why isn't this a prime factorization? 2 is a prime number, but 50 is not prime. So even though 2 times 50 makes a factor string, it doesn't make the longest factor string, which is made up of all prime numbers. So you might ask if we could continue this green factor tree. So let's make a copy of it and bring it down here and see what happens. I can take the 50 and break it down a little bit more to be 2 times 25. Now, this is a prime number, so that's the end of that branch. This is a prime number, that's the end of that branch. But since 25 is not prime, I can continue on and figure out that I can multiply 5 times 5 to get 25. And now I have prime numbers at the bottom of my branches. And once the bottom of your branches has all prime numbers, that's the biggest factor tree that you can have. And that gives you this nice long factor string that we call the prime factorization. So even though you might start your factor tree different than the person next to you, if you continued the factor tree down to all prime numbers, you would end up with the same prime factorization. So the bottom question, let me bring in another page here. Here, the question that I have here is, how can you use a factor tree to find the prime factorization of a number? Well, let's see if you can do one of these by yourself. Maybe on a piece of notepaper, you could try to find the prime factorization of 36. So first pick any two numbers you want to multiply to get 36. Some of you might pick 6 times 6. So a factor string for 36 is 6 times 6, but it isn't the longest factor string. Now, since 6 is not prime, make a little tree under 6. Think of a way to get 6 by multiplying two numbers. Hopefully you can think of a way to get 6 by choosing 2, since 6 is even. 2 times 3 is a way to get 6. So another factor string could be 2 times 3 times 6. Because 2 times 3 times 6 also equals 36. When you look back at your factor tree, you notice that 6 is not prime, so you could put another tree, set of branches under 6, and do 2 times 3 again. Now the bottom of your tree is all prime numbers. So not only is that another factor string, 2 times 3 times 2 times 3, that's a factor string for 36, but the prime factorization of 36 is made of those four numbers. Usually what we do when we write the prime factorization is we write them in order from low to high. So the prime factorization of 36 is 2 times 2 times 3 times 3. And I just put the numbers from low to high because it's just easier for people to compare answers when we add order to the final answer. That's all of the information you're going to need to be successful in the beginning of Unit 3. So thank you for listening. Come back and be ready to work these problems.